Welcome to the last lecture in scheduling projects. In this last lecture we'll look at the actual scheduling, what we might think as bringing reality into our model. So we've worked through defining activities and sequencing activities. So sequencing activities is the project network. We then looked at estimating resources and activities. They went together because sometimes the resources we use affects the activities. In this last lecture we talk about developing a schedule, the things that actually you plan to do. There are two components. Firstly, the component of the model, that's steps 2, 3, 4 and 5, and then to develop a schedule you might have to bring in constraints. Resources aren't available at certain times. You don't have you're not allowed to work on a weekend. Whatever it happens to be, these constraints will affect the actual dates that you plan to do things. The model is just how many days before you can start the next activity. So when we start with a scheduling problem, we first want to look at what is possible. That is, what can we do? And we look at an early start project network. So if you get a chance, there's an ancillary video available on the site, and it works through a forward pass and a backward pass. So there are two methods for evaluating or solving a project network. And that is the two-pass method, being the forward pass and the backward pass, or the enumeration, that is to work out the length of every path through a project. So if you think about a project as a sequence of roads, they're your links, and nodes or cities, that's your activities. You need to complete all the activities to get to the end, so you can imagine there are different ways to traverse through that project network. They're called paths. The critical path is the longest path through the project. Okay, being the longest path, that determines the earliest possible time you can finish the project. So here we have a project network. We have about 7 activities. You can see we've got a code in the lower right hand corner where we've got the activity name in the middle. We've got early start in the top left hand corner, early finish, that's EF, then late start and late finish, and on the left in the middle we've got something called float. In the labs we will have called that slack. Alright, so here's a project network. We've got our activities, we have our durations. For example, acquire a prototype of materials is 20 days. The two-pass method, let's go through it. Forward pass, that determines how long the project will take, and it tells you what are the earliest start times and earliest finish times for each activity. So here, the earliest start time for A is time 0, but activity B cannot start till A is finished, so its earliest start time is, that's right, 5. So here's the legend again. Earliest finish is the earliest possible time an activity can finish. Earliest start is the earliest possible time an activity can start, and that's obviously dependent on what needs to be done beforehand. In this diagram, and you can pause after I speaking in a moment, you can see the earliest start and earliest finish. So it's going from A, B, C, G. We have A can start at 0, finish at 5, and that means B cannot start till 5 is 20 days, so 25 days later it can finish when C can start. And you can see that C can finish at 35 days, however you cannot start part G because you still haven't finished activity F, which cannot finish. The earliest finish time for that is 45 days. That's why G is delayed. The longest path through this network, just get a pointer option, is here. Okay. You can see that's the one that's forcing the project not to finish till the day 70. That's your critical path. We can use a backward pass to identify that critical path, but it's also tell us where the float or slack is. So late start is the latest time. So we can delay an activity to a certain time, then we've got to do it, otherwise it will affect the project completion date. Late finish is the earliest time, the latest time a task can be finished before it affects the completion of the project or estimated completion. So a backward pass, we've just done the forward pass, we've gone early start, early finish. A backward pass is all about calculating the late start and late finish, and then identifies the float. So here we go. Here you can work through this on your own, but we've got the latest start time for perform sales calls is 45. So all of these, their latest finish time is 45. Then if you remove the duration, that's where you get the 35 from, and here as well, remove the duration, that's where you get the 15 from. The difference between the early start and early finish for conduct marketing is 0. Oh, that's a 0. That's your float. So there's no float here. So that if there's no float, this must be critical. Same here, and here, and here. So a critical path is the path in the network that has no float. You can see here the difference between 35 and 25. There is 10 days float here and 10 days float here. Doesn't mean there's 20 days float, because if we delayed this by 10, that becomes 35. Then we've delayed by this by 10, that's 35, 45, 55, and then we're delayed. Okay, so that can't be 55, it must finish by 45. So there's 10 days float here, 10 days float here, but what that means is for activities B and C, the total float, right, this says total. The total float is 10 days for those activities. For activity E, the total float is 20 days. So it's a difference between the early start and the early finish. Alright, so as I said, there's an activity on the ancillary video. We work through project networks in doing exercise 2, critical path method, in the labs, and we'll work through that in the lectures, in the face-to-face lecture. So we'll do an example of these. So come along to that. Plenty of opportunities to practice this technique, but you need to do it. You can't just watch me talking on the video and expect that to happen. I'm going to pause now. We'll have a 5E part 2.